Okay, hello and welcome to a coding challenge. Google Chrome Dinosaur Game Edition. Unfortunately, I don't have my train whistle. I didn't bring it with me today. I know, so this is definitely not going to go well. Not that any of my coding challenges ever go well, but I'm going to give this a try. I'm going to attempt to program quickly the Google Chrome Dinosaur game. I'm going to use my own images and stuff, so it will be the unicorn game, of course. I'm going to use P5.js, the JavaScript library P5.js, and I'm going to interact with it in a unique way that you have to stick around for the end of the video. I'll just tell you now. I'm going to try to control it with my voice. Okay, so you skip to the end. Maybe I'll be doing it there. Okay, so here we go. Let's get started. So what do I need to do? So first I'm going to add, I'm in the P5 web editor, and I'm going to add a file. I'm going to call it dino.js. Even though it's not, no, let's call it unicorn. Unicorn.js. And that's going to be my unicorn. And what do I need? I also need to have, those are like cactus thingies. I mean, those are going to be trains. So I'm going to make a train.js, add file. So let's start by creating the unicorn, class unicorn. So I'm going to use object-oriented programming because, you know, I do. Basically, this, by the way, is exactly the same as Flappy Bird. So I'm really just doing the same thing over again, but whatever. This is a nice beginner-friendly challenge. So, and maybe using object-oriented programming is a little bit overkill. But let's give the unicorn a x location at 50 and a y location, which will be height because it's sitting at the bottom of the window. But maybe I'll say like height minus 50 right now. And then I'm going to create a function called show. And I'm going to draw it. I'm just going to draw it as a rectangle right now at this.x, this.y, and I'll make it 50, 50. So this is the unicorn class. A unicorn object has an x and a y, and when I draw it, it's a rectangle at that x and a y with a width and height of 50. And those will probably need to be variables eventually. So let me make a variable called unicorn. I'm going to say unicorn is a new unicorn. And I'm going to say here, unicorn.show. And let's run this. There we go. Oh, okay. So of course I forgot what I always forget, which is that I've added some new JavaScript files, and I need to reference them in my HTML. Unicorn, and what was the other thing called? Train. All right. So that's a unicorn. And what I want is, let me play that game again. How does it work? It just sits there. So every time I press the space bar, it jumps. So let's get it to do that first. Okay, so what does it need in order to be able to jump? It needs a velocity, a speed along the y-axis. So let's call this vy, and we'll say that's 0. And we'll write a function called jump, which we will give it kind of this like instant force. So we're going to like push it up. So I'm going to say this.vy equals, let's say like -5. That's moving it up. And then I'm going to write a function called move, which says this.y plus equals this.vy. So what we should see now is if I say unicorn.move, and then if I add function key pressed, and say if the key is the space bar, unicorn.jump, this really is basically the same as Flappy Bird so far, then we should see that velocity kick in. So I'm always moving it based on whatever that velocity is, but the velocity is 0, the speed is 0, but as soon as I say jump, it sets the speed to -5, and we should start to see it move up. Okay, here we go, and I'm moving along here. I'm going to press space. There we go. Ah, goodbye, unicorn. See you later. All right, so we need gravity. So we need some form of gravity, which probably makes sense as a global variable, but I'm just going to, since the gravity is really only going to affect the unicorn, I'm going to put it in here. Let's say it's a 0.5. So gravity is, in a way, a counteracting force. So no matter what it's doing, the gravity is always adjusting the speed of the unicorn, the acceleration, basically. So what I could do now also in move is say this.vy plus equal this.gravity. However, I don't want to ever let, you can see now it's gone. I don't want to ever let the unicorn fall off the bottom. There should be basically a ground level. So I'm going to do that. Let's say so let's make this 50 a size. Let's say r equals 50. So we're going to kind of use that for all the parts where we're drawing. And then I'm also going to say, I'm going to have a constraint. So I'm going to say this dot y equals constrain its current y value between 0 and really where it's sitting at the bottom, which is also height minus this dot r. So it's stuck there, and now if I press space, you can see it jumps. Now that's a very measly little jump. We need to be able to jump much more. So let's set this to like 25, and let's see what happens. Okay, that's too much. Let's just set it to 10. And maybe I need to make the gravity stronger too. So there's going to be a lot of fine-tuning of this, but let's just do that. And let's set this to 25. Whoops. And maybe let's set the gravity to 2. There we go. This feels a bit more like the dinosaur game. So this is kind of sad. Let's make our unicorn look a little bit more exciting. Let's load an image. So I have on the desktop here, I have some images. I have a background, which will be the background of the game. I have a unicorn. This will be the character with a little angry equal sign sitting on it. And then the train will be the thing it has to jump over. So so what I'm going to do here is I'm going to add these files. I'm going to do add file, and I'm going to drag them in to the web editor. It uploaded all of them. And then in here, I'm going to add preload. And I'm going to have let u image, let t image, and let background image. And let's load all those. U image equals load image, unicorn.png. And we'll do the same. For t image and background image, this is train, and this is background. Let's change the background to, so what did I get wrong here? Background is actually a JPEG. So let's have the background now be background image. There we go. And let's have the unicorn, where is it be? I'm going to say image, unicorn image. There we go. Oh, it's so tiny. Oh, it's all pixelated. It's so sad. Let's change this to 150. But its x value shouldn't be, it should be here. There we go. So there's our jumping unicorn. But this is not a lot of screen real estate to work with, so let me actually load a background image that's 800 pixels wide, which I think will be a little better than 600. All right, my unicorn can jump, and I've made the background a little wider, which means now I need obstacles for it to jump over. And those are going to be little train things. So I'm going to make another class, call it a train, choo-choo. I'm going to give that a constructor. These will have also an x and a y. So the x will be, it's going to start off the edge. And the y will be actually also at the bottom. So height minus, I'll give it a size. And this dot r will be 100. And then, so now I need a show function. And that I'm going to draw as an image. My fingers are in the wrong place. The train image at x and y. This dot r. And let's also add a move function. And we'll say this dot x minus equals. And so the train, so this is a weird thing. It's supposed to be, this is going to be a problem. My fixed background is going to make this visually a problem. And people in the chat are saying parallax background, please. All right, so maybe I'm going to get to that. This is going to end up being a longer video if I implement that. But really, the unicorn is moving. So the unicorn is moving, but the x stays fixed. The trains, the trains could be moving if they're trains. That's weird. But they're supposed to be cacti. They're standing still, and the unicorn's just approaching them. But we're seeing it from the unicorn's point of view. I've really botched this. But what I'm going to do is just move them by, the whole scene is scrolling by 3 pixels, and we'll figure out if we can parallax the background maybe later. what do I even mean by parallax? To make it appear as if the background is changing, but off in the distance, so it's sort of moving at a different speed. But for now, let's just do this. Let's create an array called trains. And we're going to say train in setup. Well, actually, you know what we're going to do in draw? We're just going to randomly, we're going to pick a random number between 0 and 1, and we'll say like 1% of the time, we're going to say trains.push. We're going to add a new train. So it's going to be irregular. This is different than the Flappy Bird I made where I think the pipes, maybe it was irregular. I think the pipes were at regular intervals. Now there's a random chance of adding a new train, and then all of the trains that exist, we're going to say for all of the train, I'll just say t in trains, I'm going to say t.move, t.show. All right, let's see what happens. Do we have a train? Maybe I better increase it. Oh, we go. Oh, look at that. All right, they're moving. They're kind of slow. I'm going to jump over it. Oops. OK. Let's make them move a little faster. So we've got some tweaking we've got to do. Whoa, this is a nice way. Now, look, my unicorn can fly. So I need to fix the fact, I need to like not allow my unicorn to fly, right? I should only be able to jump if I'm at the bottom. So let's fix that. So to do that, I need to go into unicorn. And in the jump function, I should only be allowed to jump if I'm sitting at the bottom. So in other words, if y is, if I'm at the bottom. So as long as y is equal to, is this really going to work? I don't like to use equal checks, but this is by definition sitting at the bottom. So only if I'm sitting at the bottom can I jump. So if y is equal to that spot. Let's see if that works. So jump. Oh, this dot y. Come on, trains. Oh yeah, yep. I can only jump when I'm at the bottom. All right, so that works. So that fixed. I think I need to be able to jump quite a bit higher. Let's try 35. I should really use like a slider or something. There we go. I think this is going to make the game more possible to win. There's too many trains. Too many trains. One thing that's bothering me is the trains are going in front of the unicorn. I know that doesn't really matter so much. It certainly doesn't matter. But I kind of would prefer them to be behind. So I'm going to move this here. I'm also going to make the game a little easier to play. I'm going to reduce the number of trains. So there's going to be a much lower probability of there being a train. Let's see if I can actually play this game somewhat successfully, even though I'm not doing the collision checking yet. No. I think if the trains move faster, it would actually make it easier. So let's actually double the speed of the trains. All right, this looks like this game is now possible to play. But I need to add collision detection. So I've done this before in plenty of other coding challenges. There's a pretty simple algorithm to just check if two rectangles are intersecting with each other or not. I can just check their x's and y, they're basically all of the edges, the left, the right, the top, the bottom against each other. But this is a nice opportunity for me to just explore a library that's out there in the world. And this library is called P5 Collide 2D. And it actually has a function in it called collide rectangle, and it'll give me a Boolean variable if I give it the x, y width height of one rectangle and the x, y width height of another rectangle. So let's actually just use this library. This is also a nice excuse for me to show you that GitHub is now integrated with something called JS Deliver. So this is an open source content delivery network, meaning if a JavaScript file is hosted on GitHub, I don't have to download that file and then add it to my project. I can just link to it. So I'm going to go over here to GitHub. There's lots of different ways here that I can reference a file on GitHub. I think the easiest way for what I'm doing right now is just to reference its path. And here's an example path. So I'm going to go over here to index.html. I'm going to add another script tag. I'm going to say script source equals. I'm going to paste that in. Close script. But this is not the path that I want. I want the username, which is BMOREN. And then I want the path to, let's get the minified version of the library. And that would just be this, right there in the root directory. So now I'm just referencing that file. Let's see if that works. This is actually not correct. I'm referencing the CDN URL, the username, but I also need the repo name. So that should be p5.collide2d/this. So this should now work. Okay, and I should be able to use the collide function. So I'm going to use this collide rectangle. Let me just call this in draw to see if that works and doesn't give me an error. Great, no error. And so now I can check when I'm going through all of the trains if unicorn hits T console log game over. Okay, so console log game over. And then I'm actually going to say no loop. So I'm just going to actually stop the sketch, shut down the sketch completely, which isn't a really thoughtful user experience design choice, but it's what I'm going to do for right now. And then I just need to add a function here called hits and receives a train. And I can say, I can use this function, which I need this.x, this.y, this.r, this.r, and then I need exactly the same thing, but with that particular train. So instead of this, I'm checking this rectangle with this train's rectangle, and I'm going to put this in a variable called collide, and I'm going to say if, I'm going to return that. Actually, you know what? I'm just returning this. Return that. So return the true or false result of this collide function from that library. And now let's run the game. We'll wait for our first train. Game over. Let's see if I can play it now. Oh, there were so many trains a while ago. Oh, shoot. Let's make the train a little bit smaller. And actually, let's make the unicorn smaller as well. Hopefully this will help. All right, let's draw the box. Let's debug this a little bit by drawing the box, like very subtly. So let's draw a very slight rectangle. This is what we're actually checking. There we go. Woo-hoo! It helps to see the full box. Come on, trains. Spawning a train with a mouse click would be a good idea. Okay, we lost. All right, so there's obviously a lot of gameplay improvements that need to happen here. One is I could be more thoughtful about, and you can see how there's some like wasted space here. I should crop the image and the actual rectangle a little bit smaller. I could consider using a circle. I could use a more complex shape, but this is good enough for right now. Let's actually make it, I could also like just click the mouse in order to start a train. That actually might help things, but let me comment out this. And what I want to do just before I finish that, you're going to make a version of this with a score and all sorts of nicer things and sounds, but I got to finish this off. I got to finish this video. I want to control the train with my voice. So to do that, I'm going to use ML5JS, which has a speech commands machine learning model built into this JavaScript library. So I made a whole separate video about this particular pre-trained model and how it works. So I'm just going to add it pretty quickly into this video. You can go watch the other one for more details. But if you're looking for the documentation, if I click on reference and go to soundClassifier, this is what I'm looking at doing. So first thing I need to do is, one thing I need to do is I need to go to get started, and I need to get a script tag to be able to reference the library. So I want to add the ML5 library, so I'm copying this. I'm going here to index.html. So in addition to p5 collide 2d, I'm now adding ML5. And I'm going to go here. And I'm going to, in preload, I'm going to do let sound classifier. I'm going to create a variable. In preload, I'm going to say sound classifier equals ML5 sound classifier. And the model I'm loading is called speech commands 18W, because this is a model that's been trained to recognize 18 particular words. The digits 0 through 9 up, down, left, right, and a few other ones that are documented on this ML5 webpage. Let's go look that up real quick. So if I go back to soundClassifier, up, down, left, right, go, stop, yes, no. So those are the words it's trained to recognize. And I actually also want to get this probability threshold. So I'm going to add this in here because I want it to be really sure I'm saying jump. So I'm going to make this 95. This means it's got to be 95% sure, the confidence score that's coming from that particular model, and how that model was trained. And there's a whole paper you can read, and I've talked about that more in the other video. Okay, so now that I have that, in setup, I can say soundClassifier.classify. Then I can get a function. I'm going to call it got_word. So it's got a word, got command. Let's call it got command. So this is a callback function that is going to trigger anytime it gets a command. It gets an error first callbacks, and then the results. So I'm going to say if there's an error, console. I'm just going to console error the error. Otherwise, if results index 0.label. So results is an array with labels and confidence scores. And the labels are the words, and what I'm looking for is the word up. If that label is up, then unicorn jump. So this is a really quick way of me looking for a particular keyword from that library. And I'm also just going to console log results index 0 dot label, just to see if I'm getting other words also. And we might as well log the confidence score just so we can see that. That might be good for debugging as well. So now that I've logged those two things, I'm going to run this sketch. Up. 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 Shoot. But you can see it got up 95%. I'm going to add the thing where I click the mouse and I can give myself a train. And in fact, let's comment out the random trains. Also, I really should be more thoughtful about how I'm picking the train, like when the train should come. Like maybe there's a minimum distance between them. If I've just added one, can I have a longer train with other train cars? I don't know what's going on here. There's a lot of narrative flaws in what's going on here, but I'm just going to add one myself. Up. Up. Shoot. All right. Everyone is making the suggestion in the chat that I should change it to a circle. So that'll actually kind of be like a rounded, it'll give me a little wiggle room along the edges and make the intersection happen a little less often. So let's actually go ahead and do that. So I'm going to go into where the only place where I'm doing this collision detection is where? In the unicorn under hits. So I'm going to change this to collide circle circle. Collide circle circle. And circle to circle assumes ellipse mode center. So I'm going to have to think of the circle as the center point of the object, which is not a big deal. So the way that I'm going to do that, let's make some separate variables. Let's say x1 equals this dot x plus this dot r times 0.5. So this would be the middle. This is the middle. And then r is the diameter of the circle, so that's fine. And this is y. And then x2, y2 is the train. Train.x, train.y, train.r, train.r. And so now I want collide circle, circle, x1, y1, and then x2, y2. The question is r for actually the radius or is it the diameter? Does it say? Circle diameter, so I'm good. All right, so let's try this. And then this should really be, oh, this is kind of unfortunate. This should now be an ellipse. But oh, you know what I can just do? I can say ellipse mode corner. Perfect. So let's draw the hit circles. And under train, let's do the same thing here and say ellipse there. So this should now, we should see, here we go. That's what it's going to do. Okay, here we go. Oh, I have to click. Oh, whoa, what happened? All right, I passed R in twice, which is very unnecessary. You just give it the diameter, not the radius, even though I'm calling it R once. And let's see what happens. Okay, here we go. Jump. Wait, why is my browser really freaking out? Let's comment out the debugging. We're just going to go for it now. We're going to play this game. I'm going to close this tab. Quick Chrome. We're about to play this game. Oh, up. It's up. I'm saying jump. Oh, up. Yeah, there we go. Up. 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 All right, ready, everyone? Up. Up. Maybe, I guess I can't use the music. Up. 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 Oh! All right, everyone. Thus ends this coding challenge. There are so many things that need to be added to this. Number one, the narrative makes no sense. Why is there this unicorn standing still without any animation? The trains are coming at it. The background should be sort of like in parallax moving. So probably it should be jumping over. I should have just used cacti. That's the plural of cactus, right? There's no score. There's no birds flying. You could add a flying asterisk. When I upload this, I'm gonna include when this video publishes, and with the code, I will include a lot of the coding train characters, which are designed by Jason Heglund, illustrated and designed by Jason Heglund. So I'm gonna include a whole bunch of those if people want to make a version of this game that we can all play online with speech commands. Let me try this. I'm gonna just say goodbye by trying this one more sentence. And yes, Alka is pointing out that speech detection API in the browser might be lower latency, but let's try this one more time. Up. 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 Oh, okay. Goodbye, everyone. Thank you very much, and see you later on a future coding challenge.